Hi, this is Randall Schwartz, host of FLOSS Weekly. This week, Jonathan Bennett joins me. We're going to be talking about the Rust programming language, a new language with good concurrency and good for systems programming. You're not going to want to miss this, so stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for FLOSS Weekly is provided by CacheFly at CacheFly.com.
This is FLOSS Weekly with Randall Schwartz and Jonathan Bennett. Episode 477, recorded March 28th, 2018. Rust. This episode of FLOSS Weekly is brought to you by IT Pro TV, binge-worthy learning for IT pros. Visit itpro.tv/floss and use the code FLOSS30 to get a free 7-day trial and 30% off a monthly membership for the lifetime of your active subscription. And by Kubernetes Engine on Google Cloud Platform. Learn more at g.co/getgke today. It's time for FLOSS Weekly, the show about free, libre, open source software. I am your host, Randall Schwartz, Merlin at Stonehenge.com, bringing you each week the movers, the shakers, the big projects, little projects, projects you may be using every day and unaware of it, projects you might want to start playing with right after this show. I think today is going to be one of those. Joining me once again is my lovely and talented co-host, Jonathan Bennett. Jonathan, welcome back to the show.
Thank you, Randall. It's good to be here, and welcome back to you as well. Randall was out last week.
I was so sick last week. Something in the stomach, not quite sure, but for about 24 hours, I couldn't keep anything down. I'll just leave it at that. But I did finally get healthier, but it wasn't until like 2 p.m. on the day that I was supposed to be taping last week's show. So I spent a lot of time binge watching Netflix while groaning and being horizontal and running up to the bathroom every hour or so. Yeah, it was not a very pleasant day at all for me. So that's 2 shows in the last 4 weeks that I've missed by being sick. I need to up my game a little bit, I guess. So we'll figure out how to make that fix. But I am back home. I got home late last night, so not quite totally caught up in my sleep yet. You know, on a travel day, there's just so much activity. I got up early in the morning, and I was in airplanes for 3 hours and airports for about that same amount of time and running around from place to place. So I'm a little slightly underslept, but we'll manage anyway. The show must go on. The show must go on. So today, very special treat. I say that almost every time now, but very special treat. People have been asking me to do a show about Rust for a long time. Rust, the programming language, and we have a really good guest on today for this. Ben Striegel is going to be coming on in a few minutes. I saw his talk at All Things Open I think it was last October, last November, something like that. It was a while ago. And I really said, you know, there's more to Rust than I'm aware of. I thought it was just yet another programming language, but there's a lot going on with it. And he was not actually talking so much about the language, but about some application that he was writing. But I saw some really cool features there, so I had to have him on this show. And we finally connected up after a few months, and he'll be on today in a few minutes. What do you know about Rust?
I know that Rust obviously is being done by Mozilla, same people that make Firefox. Yep. And they are looking to at least some extent replace C as a systems language, but they're trying to make a better and improved and safer version of C. And I know they also have something very interesting called a crates system, very similar to Python's pip or Perl's package manager, which should be really interesting to talk about too. So some very interesting potential with Rust. I'm looking forward to getting some questions in and learning more about it.
Yeah, the homepage for Rust says it's a systems programming language that runs blazingly fast, prevents segfaults, and guarantees thread safety. That's a tall order. So we'll see how Rust actually came into be and all of that stuff. But unless you have anything else to add before we move. Yeah. So I'm speaking to you from my home. I said that already. And you're speaking to us from the same normal place, right?
Yes. I'm here at the corporate headquarters, the home office here in Lawton, Oklahoma.
You see, I miss a week and I forget how to do this show. I've only done, 400 shows, but I still forget occasionally how to do this stuff. But they let anybody run their show. So, excuse me. So let's go ahead. Well, no, we have a very important message before we continue with that, because this episode of FLOSS Weekly is brought to you by IT Pro TV. Build or expand your IT career with IT Pro TV. IT Pro TV offers over 3,300 hours of binge-worthy, on-demand training with more than 125 hours added weekly. You stream IT Pro TV's courses live and on demand worldwide via Chromecast, Roku, Amazon Fire TV, Apple TV, PC, or by using their iOS or Android apps. There's no need to go off-site for training. Seasoned IT pros understand the importance of continued education for career development. IT Pro TV does it IT live every day, so you know you're getting the most current IT training. Courses include Certified Ethical Hacker, Kali Linux, AWS, ITIL, and ISC Squared Security. If you're interested in an IT Pro TV team solution, contact them for group pricing. You can track your team's results and prove the ROI of your training spend with IT Pro TV's Supervisor Portal. You gain full control over your team's training schedule so you can create custom groups with training assignments. See individual and group analytics, logins, viewing time, video downloads, and of course, completion tracking. Whether you're eager to start your new career in IT, or you're a seasoned pro, or you're looking for an engaging way to keep your team up to date, IT Pro TV offers effective and entertaining IT training. Visit itpro.tv/floss to learn more about IT Pro TV's team solution and to request a free team trial. Or sign up for an individual monthly membership with a free 7-day trial at itpro.tv/floss. Use the code FLOSS30 to receive 30% off your subscription for the lifetime of your active subscription. Premium subscriptions, which include unlimited Transcender practice exams and virtual labs, are normally $857 a year, but you pay only $600 when you go to itpro.tv/floss and use the code FLOSS30. Flexible training, binge-worthy content, ROI proven. Join the more than 90,000 IT Pro TV members today, and we thank IT Pro TV for their support of Floss Weekly. Let's go ahead and bring on our guest. Ben, welcome to the show.
Hi, folks. Good to be here.
And where are you speaking to us from?
I'm actually from Berlin. It's funny that you should mention travel because I have flown like 12 hours this past week, and so I'm also a little bit jet lagged, and we'll see how well Skype holds up over international boundaries.
Okay, so you're actually in Berlin right now?
Yeah, so what's happening is the Mozilla All Hands, the Rust All Hands, but we're at the Mozilla offices in Berlin. And so kind of like Rust has a very interesting kind of governance structure. It's pretty distributed all around the world. And so like once in a while we get together and we have all our different teams get together to like talk about like cross-cutting concerns and all sorts of things like that. And it's been a very productive week so far. Some really cool things coming out of it.
So do you have a clever name for whatever it is, like RustConf or whatever?
No, RustConf is the name of our annual conference for users. This is just the Rust All Hands. It's a very core developer, core team focused event. We have about 50 people here at Mozilla's invitation.
Awesome. Okay, so let's back up a step. So Rust is a programming language. We made that clear, but yeah, there's a lot of programming languages. What makes Rust different?
Oh, what a good question. Well, I like to say that Rust is kind of you've heard of some languages described as like, cross paradigm. Rust is really kind of a cross programmer language because it's not like you wouldn't think. Let me rephrase that. So I know people who come from Rust from like, C backgrounds, assembly, embedded, and like C++ backgrounds. But I also like people who come to Rust from like JavaScript or like the highest level things imaginable, like the very like functional dynamic languages. It's kind of like, it's sort of almost a way of like unifying the two concepts in terms of like, a systems language that has kind of like the sort of like functional-ish modern features that you kind of expect from like a typical like language these days, like closures, sort of map fold operation. Although I wouldn't characterize Rust as functional, but it's also incredibly fast, a very modern compiler, sort of like state of the art in some ways. We have some dark corners, of course, and it's what makes it different. I think what makes it different is that we compete in a part of the language space that has historically been very hard to compete in. And you may notice, like, in the 90s, it was kind of a big thing, like so many of these dynamic languages. Python arose in the 90s, Perl, Ruby, and that's because it's really hard to make a language. It's hard to make a language that's, like, really, really fast that can compete with C, like, at runtime. It's also not fun. It may be hard to make a good language like Perl or Python or Ruby, but it's also really fun to design a really elegant language, right? Where you kind of like, just like, what is like the most like elegant way of expressing this? What would be the easiest way? And with a systems language like Rust or C++, you have to make a lot of compromises because you care about performance. You care about the machine system and like peeling back abstractions and layers and giving people the real like control over the hardware that they really require for this domain. And so it's weird because like people don't usually like, if you're just like an individual author who wants to make a language, which like so many programmers are, as like so many languages begin, like, Larry Wall just starting with Perl as his own little project, or Rasmus Lerdorf with PHP. You don't usually see a language at this level. And I think thanks to LLVM, which is like the Apple, but also a community project that makes it possible, because we can finally focus on like designing the language itself, making like really cool features without needing to go through and optimize individually for every single arch that we want to support.
So how did Rust get started?
Well, like I said, so most of the languages like start with one programmer kind of just like working in their basement trying to scratch their own itch. In this case, it was a man named Graydon Hoare, who has worked for the currently, or let me get back up. So he worked for a really like foundational version control software. It's one of them that predated Git. In fact, it's famous because there's a commit from Linus Torvalds in there where he adds like Merkle tree support to it, which we think might have inspired the like Merkle tree approach in Git, which is obviously pretty famous by now. But it was one of the earliest distributed version control systems. And so he was working at Mozilla for a while, working on the JavaScript engine there, doing some optimization work, like theoretical, like tracing just-in-time compiler work. And at the same time, he also had to work with C++ because that's what SpiderMonkey is written in. He does some Firefox things at the time. And also, like, working for Mozilla, one of the things that you care about, as any web browser does, is a security profile. In terms of like, we have users who are really running untrusted JavaScript code in their browsers. And also like HTML, CSS, a lot of these things, if they're implemented poorly, they can serve as attack vectors to a user's computer. And that's obviously very bad press. And also, like, if you don't care about marketing as a moral thing in terms of like, well, we want to protect our users, it's a pretty good thing too. And so they looked at like various ways of like, well, how can we like instrument C++ to make it like safer? Like, is there like, what's like the state of the art out there? What are the research languages? And there's some things that you've probably never heard of, like Cyclone, if you want to like research more about like where the history of Rust came from, just some ideas that currently made their way into Rust through very circuitous paths. And so he worked on this starting in about 2006, just by himself. And then at about 2009 or so, he had the courage to show his employer, hey, I have been working on this thing for a while. And Mozilla at the time was kind of like really going all in on like very long bets. This was the time of like Firefox OS, the whole bootgecko thing. And they were kind of like, yes, we want to fund you to do this in their R&D department. And so they gave him one engineer, Patrick Walton, and they just set out to build this thing to sort of a minimum viable product state. And that pretty much arrived in about 2011 when they actually rewrote the compiler from OCaml to Rust. And so it became self-hosted at that point, which is kind of a major milestone, kind of like maybe the birth of Rust. But it wasn't actually usable for about 4 more years. But really, it's even though it's from Mozilla and Mozilla Engineer, like it's been like all Mozilla products kind of like very open from the start. And it really by now it is very largely a community project. There's like even among the governing team, less than a third are Mozilla employees.
Well, wait, if it's self-hosted, what did I just compile yesterday on my laptop? Something compiled at MacBoards.
Ooh, I could go on for a long time about self-hosted compilers, which also includes the Go compiler, GCC, and Clang. They're all written in C. Clang's written in C, and compiles using Clang. And the short of it is that you compile a version of the compiler using yesterday's version of the compiler. And that version of the compiler is compiled using the day previous version of the compiler, and on and on and on, kind of down the chain, tracing back to the original OCaml compiler from 2011, which was abandoned back then. And you can feasibly imagine doing some archaeology to kind of retrace your steps all the way from the past to the future. But it would be pretty painful because we have thousands of intermediate builds by now.
I guess it's sort of like, I'm a big fan of the Smalltalk, and I actually used Smalltalk back in 1982. And that same Smalltalk 80 image basically kept squirting out copies of itself as it went forward and forward and forward. So you can still actually use I think the true and false are actually just clones of themselves forever. They actually have like the longest history of anything, true and false, right?
Rust has a few things like that, as well as Clang. We've seen it before, where, for example, in the source code, like the byte for null, it is defined as just being like, so \0, the escape sequence. Yep. It's just defined as being the value \0. We're not sure where in the code the last null actually appeared. It might have been in no-camel. So
okay,
it's really funny.
That's way deep geeky stuff. Let's bring it back more to a little bit more mainstream. So Rust is primarily being used these days by Mozilla for what? Is it part of the browser? Am I running Rust code when I'm running a Mozilla browser?
You've been running Rust code. If you use Firefox, you've been using Rust code for over a year now. It really got big last October, for the Firefox 57 release, which was codenamed Quantum. It was a big marketing push because this is the turning on all of the Rust stuff. They kind of like had been rewriting various bits of the browser in Rust for the past 4 years. It was a R&D project called Serva, which is still going on, and they prioritized various parts that they wanted to bring up into Firefox. And obviously the reason Mozilla funded this is because they wanted someday to have some of this tech be in their browser, and it finally actually paid off. It was like, I mean, I can't express enough how ludicrous the idea is of, we have this product and we are so dissatisfied with the current state of it that we want to rewrite or write from scratch an entire new language and then rewrite our product in this language. But I mean, it's happening. Nobody would have thought. I've been involved in this project since 2011, and I think it is the fact that this is actually succeeding is like, wow, I did not expect to actually be here, because most languages tend to die very young. You don't get traction, and just people lose interest. And Rust has succeeded beyond my wildest dreams. It's obviously not the biggest language in the world, but the fact that I'm here at all, I got paid to fly across the ocean to come just talk for an entire week with people about this language, this project that I really enjoy and really just I love working on, and it's just so cool.
And so, actually, that begs the next question, which is, what's your role with the Rust project?
So, as I mentioned, Rust is kind of a distributed team, and so we have various sub-teams within Rust. And so I am on right now the community team, which is my official role, and I do various outreach with Rust. I do teaching sessions like you saw at ATO last year. I host the Rust meetup in Boston. I do all sorts of things involving switchboarding. So if somebody wants to have their own meetup in Bangalore or New Delhi or South America or anywhere like that, we're like, hey, here's some resources. Here, let us know how we can help. If we can find you contacts, if we can find people in your area using Rust, you can get to speak. Kind of just connecting folks together. And that's mostly what go on.
I was just going to say, I was going to jump in. When you took a breath there, I'll jump in. You said something a minute ago that I find really interesting and honestly maybe just a tiny bit worrying. Rust is self-hosted. Can you only compile Rust with Rust? So you described this this chain of events where yesterday's version of Rust compiles today's version of Rust. Is that hard-coded and baked into the project that's the way it works?
The way it works is, we have a policy about this where, so Rust C is the name of the compiler itself. It is a code base written in Rust. And we compile using the previous the previous version of Rust. So it's interesting, our release model. So we're from Mozilla, kind of inspired by the organization. Your web browser, if you use Chrome or Firefox, releases every 6 weeks, which the idea is to make it so that people writing features don't feel pressure to rush their features to get things out if there's a very long release window of years, like it used to be in terms of there's a lot of these Java big updates that kind of push back, Java 7, the coin stuff, where it just took them so long, it's delaying, and it just with the 6 week release model, you can do things really fast. And so that's how often we release. We're on version 1.26. We increment the minor number every 6 weeks, and we released 3 years ago, and it's going to get big. But so far, it's working out very well. We have a lot of new features in terms of new APIs, just bug fixes coming out all the time, and our users seem to be actually really happy about that. Some distros are not as happy about that in terms of getting Rust packaged. We are working on that problem, and we'll see what happens.
Yes, there is always the tension between release early, release often, and we need a stable version of this thing to package up. But go ahead. You can respond to that.
Well, I mean, I didn't really answer your question. Is the thing. So Rust is currently a language, unlike C or C++. Those are defined by a specification document. Rust is currently just defined by the implementation, sort of like Python is. If you recall, though, like it took C until ANSI C, so about 17 years to get a spec. And likewise, C++ from like 89 to 98 didn't have a spec. And so maybe in about, we've had 3 years of stability. Give us like, 8 more years to catch up with where C and C++ were when they got specs, and we'll see. But even though Rust is currently defined by the one code base, we do have one alternative compiler, which we have used to verify our own compiler. There's a famous paper from Ken Thompson, one of the old Unix hands, the trusting trust attacks. It's called Reflections on Trusting Trust, for anyone who wants to Google it, where the idea is that if you self-host a thing, you could insert backdoors that will propagate and be invisible in the code. And in modern times, one of the ways that you can defend against this is by, it's called diverse double compilation. Basically, it means you write a second compiler and use these two compilers to compile each other in random permutations. And this basically pretty much means that there won't be backdoors in your compiler. And this happened earlier this year. Someone just happened to write a Rust compiler in C. So that's not even like, don't worry about like any kind of like other backdoors there. And that compiler can compile our Rust compiler, our Rust C. So we're pretty sure there are no lingering backdoors.
That's excellent. You have, as a community, you have entirely predicted the question that I was going to ask and already solved it.
Yes. It's our speciality, hopefully.
Yes. So Firefox is using Rust. Where else is Rust being used, and where else can Rust be used?
We have an entire, so on our rustlang.org, we have a page that we call like the page for managers, where it's kind of like, if you want to use Rust, show your manager this page. And it's the page of production users using Rust. And it's not comprehensive because we ask companies to opt in. Obviously, we don't want people, like, even if we know someone's using Rust, we don't want to like presume that they want their logo on our site. But we have Dropbox on there. It's called the Friends page. We have like, Chef and Sentry and all sorts of like really cool projects. And I personally know of Rust being used at several major companies that aren't on that site. I talk to them all the time. One of my unofficial duties as community team is to kind of like talk with production users and like interface with them and see what they need in terms of like internal use. But there's also like various open source people using Rust too, in terms of like, so Mercurial is currently writing a lot of their stuff in Rust. So kind of like Mercurial is a Python alternative to Git. And they have rewritten, they used to just be a pure Python program with like some C extensions for speed. Soon it will be a Rust program with an embedded Python interpreter inside. And then there's like Facebook is doing some Rust stuff with Mercurial as well. Potentially others I can't talk about right now. And just, there's a lot going on. And you asked about what we can use Rust for. And it's really cool because, like I said before, Rust, it appeals to a lot of people because I come from a dynamic background, like a Python-ish sort of thing, also knowing some Java from college. And I had never like really successfully learned any systems language before because it's really imposing. In college, I remember I was a computer science major, and I remember like the classes, everyone was like, no, they're foreboding, don't take those, but like the OS class and compiler design class, and like those invariably they used C. Unlike Java, which is what we were taught. And like people are like, oh no, it's so scary. And like it really just like, and it's not like, when you get down to it, C isn't that scary. It's only scary if you try and like put things into production in ways you don't understand. And the problem is that it's really easy to misunderstand how to use C. There's not a lot of like railguards really, which wasn't a problem back when it was designed. But as things get more and more networked and like, especially with Internet of Things being on the horizon, or maybe even here in some ways, the idea of like having a C program kind of on the network, not being updated or maintained, is getting progressively scarier. And so if we want to have embedded devices that have like a better story about like security in terms of like just not having buffer overruns or the classic problems that you have with C, Rust gives you an alternative for that. But it's not just for embedded things. So like, for example, Firefox, they had kind of like Firefox is not rewritten in Rust entirely, right? It's still a huge multi-million line C++ program, but it has parts of it that are written in Rust. And so what's cool about Rust is that it's modular. So you can like, you don't need to rewrite your entire application in Rust to get the benefits because every language in the world is a cool trick. Every language in the world can speak C. There's a foreign function interface. So if you're Python, want to go fast, you can like call into C using C types or like various other cool tools like that. Ruby can do it. PHP can do it. Every language can do it because C is kind of the lingua franca. And the C interface is de facto standard on various platforms. And by pretending to be C, we can have any language call into Rust. And so we can write libraries that any language can consume, like really foundational stuff, like, various things with like regex libraries, or like, PCRE is a C library written for Perl. You can write an alternative in Rust if you wanted to, and like other code wouldn't know. And so that's really cool. You can just drop in Rust components to projects and like they'll just go faster magically. And what's cool about that too is, like I said, I'm a Python programmer, and Rust has enough safeguards that if you can just have people who have never written like C code in their life. Like you wouldn't have those people like just write C code and put it in production. But you can have them write Rust code. And what's cool is that if they were to do something that is like really bad, the compiler will yell at them. And as long as you say don't use one keyword, which is called the unsafe keyword, you can guess what it does. As long as you don't use that, nothing memory safe-wise can go wrong. Otherwise, obviously, there's still like SQL injections aren't a solved problem by Rust, but things with like use after free, iterator invalidation, double freeing, just all these pointer problems, memory errors, buffer overflows, as I mentioned, are just gone.
So that's the perfect setup for the follow-up question. You mentioned embedded devices. What about times when you're writing a kernel, you're writing something that runs bare metal on, you have only a meg of ROM or, 512K of ROM.
A meg is plenty.
So there's times, not that I've written a kernel myself, but from what I understand, there's times that to make the kernel work, you have to do some really hairy memory things. Is that where the unsafe keyword comes in? Is that how Rust can handle that?
As I mentioned, so there are these like trade-offs that various languages, if you want to be in the systems domain, have to make. And one of them is you have to be able to write assembly code. And so in C, you're used to inline assembly for if you want to just like poke things into registers or like do various really grotty like cryptography things that you want to make sure that the CPU doesn't or the compiler that is, doesn't reorder in various ways. And so Rust can do inline assembly. And also Rust can call into C code. Like I said, every language can call C. And so if you have code that's written in C, you can like put Rust on top or below or any combination if you wanted to. Just like stacking Lego bricks. But the thing is, though, that the Rust compiler, we do all our checks at compile time. And so like we care about speed a lot, obviously, because like Firefox, we want to believe that Firefox only competes on safety and security that keeps users safe. But all browsers also compete on speed, which is why they're written in C++ in the first place. Right? You can't sacrifice speed unless you wanted to lose. So Rust can't sacrifice speed, and so it does all its checks at compile time. There's no runtime penalty for like the borrow checker or the things I might mention later if you see like these things. And it's really cool because these all work even in embedded contexts. And so it's just oof. I can get into this for a while, but yeah, Rust can write. But like I said, so the static checks though they don't work on C code because if they did, we wouldn't have needed written Rust. We could have just written like a C like type checker or like static analyzer, which plenty of companies have done, but they often have false positives and false negatives. So they aren't perfect. Rust, for what it does, is perfect. It doesn't do everything. I don't want to but it does a lot more than you might think it does, actually. But yeah, that's called the unsafe keyword, and it's an escape hatch for writing like code that uses raw C-style pointers or calls assembly or C code.
And then one other thing you mentioned is the LLVM project. What is the relationship between Rust and LLVM? Does Rust compile to an intermediary that LLVM then picks up and generates actual machine code from? How does that work?
Yeah, LLVMs are a cool project from Apple. So they wrote a C front end called Clang, and the back end is LLVM. And it stands for low-level virtual machine, because originally it was a virtual machine like Java. That is no longer the case. Don't worry about that, but the name has stuck. And in the meantime, LLVM has this really nice interface, or at least very well-defined, at least well-documented. Okay, well, it's an interface, and it's called LLVM IR. And basically, it's its own language. It's kind of like a high-level assembly language, lower level than C, though. But it has various information about types to some degree that you can use to optimize. And then LLVM is supposed to be a series of passes that you can kind of plug together in various ways, kind of like a pipeline, and optimize code. So it's originally from Chris Latner, a researcher at the University of Urbana, I think, somewhere in Illinois. And I could be totally wrong. I'm sorry. So we began as a research project and just like writing a really good compiler pipeline for research. And it became Apple bought it, hired him. And it's still open source, so it's not proprietary. And it's really like kind of like providing a renaissance for like these really high performance like statically typed languages nowadays, because you can ignore almost all of the like individual platform specific optimization work or the things that have been implemented in research over and over and over again, like, you know, like it's inlining or like various like algorithms for auto-vectorization, these things that you want modern compilers to do for you to get the maximum speed, and you can just ignore all that. You can just write LLVM and kind of just plug it in, and it works. So it's basically, and that's what the Rust C will generate for you. So it generates LLVM, and then our job is done. Yeah.
So Eric Duckman in our chat room just said that he probably means Champaign-Urbana, so for the location of the person who created LLVM.
I'm sorry.
That's okay. That's okay. Well, that's why we have this crack research staff right there in our chat room.
Of course, the fact checkers.
We're our fact checkers, our wonderful fact checkers. Wonderful. Thank you for that, Eric. I've got a few questions to ask now, but before I do that, I have a very important message, because this episode of Floss Weekly is brought to you by Kubernetes Engine on the Google Cloud Platform. When you're building an application, you need it to be fast, secure, and always evolving. With Kubernetes Engine, developers can easily deploy containerized apps on a fully managed service from Google Cloud Platform. Google has been running production workloads in containers for more than 10 years, and they build the best of what they learn into Kubernetes Engine. Kubernetes Engine combines automatic scaling, updates, and reliable self-healing infrastructure with open source flexibility to cut down your development cycles and move from idea to production quickly and reliably. Kubernetes Engine handles scheduling deployment for your workloads to maximize resource optimization so you can focus on your apps. Auto-scaling allows you to handle increased demand of your services and will scale back down in quiet periods to save you money. Google is the only hyperscale cloud provider to offer an SLA for clusters running on Kubernetes. It's also backed by experts on Google's security and reliability engineering team and is both HIPAA and PCI compliant. Worried about getting locked in? With Kubernetes Engine, you're free to take your workloads out and run them anywhere Kubernetes is supported. Learn more about Kubernetes Engine at g.co/getgke today. That's g.co/getgke. One more time, g.co/getgke. And we thank Google and Kubernetes Engines for supporting Floss Weekly. So here's my take here. First, I want to correct something. You said earlier, and my ears perked right at the time. You said PCRE was written for Perl. No, PCRE.
Was I totally wrong there?
Yeah, you're totally backwards. PCRE is because everybody else was jealous of Perl's regular expressions, and so they basically took everybody else copied, and it says it's Perl compatible, but there are still things that Perl's regular expressions engine can do that nobody else can do. For one thing, have embedded Perl. You'd have to actually put a Perl thing in the, yeah, okay. I just wanted to straighten that out, just to fix that. So okay, it's good. Everybody else is jealous. Actually, there is a CPAN module that lets you run PCRE if you need its precise compatibility with PCRE. So you're running a regex engine inside Perl that's separate from the normal regex engine, which is just way too crazy. So the three main points on the front page, I think you addressed a couple of these here. So blazingly fast. How do you justify that Rust is running blazingly fast? What is it doing special?
We're I don't want to quite say that we're like inspired by C++ because people tend to think that, oh no, that means you have like templates and like horrible error messages and that kind of thing. And I mean, like, no, we're inspired by the philosophy of C++ in various ways. One of those ways is the idea is zero cost abstractions. And the idea is that you should be able to write code that is readable and has like various constructs that make it easier to understand and write the code as a human, but also that boil away to nothing. In other words, I think the way that Bjarne Stroustrup put it is that it is as efficient as you would have written it by hand. Like an abstraction should impose zero overhead for the performance, the runtime performance of the code. And so they're like really easy to point out like ways that C does this over its like forebears, right? So compared to assembly, like C has an if statement and like, instead of saying like, like that jump assembly branch, you write an if statement, which is like more restricted and doesn't compile to anything differently, or a function which kind of, instead of being a go-to, like it's totally, again, unrestricted, you have a function which constrains where you can go. And it makes code easier to understand. You remember, is it the famous essay, "Goto considered harmful?" That was in the days like before, like, so C-style gotos actually are really way safer than what that paper is talking about. And so it's weird to think of C as being the safe language, but it was for its time. And so like C++ added to that with some things with like classes and destructors, and Rust also has some ideas there too. And so our things are, so I mentioned before, we have closures, we have these fold and map, and I think that it's pretty, the typical approach people have with these is kind of like, well, they might make your code look easier. I mean, obviously it's subjective, but people might think that they like are hard to compile efficiently. And actually, they're right, but we do it. It is hard to compile them efficiently, but we do it very well. You can have in Rust, for example, imagine you have kind of a range of integers. So like, bracket 0 to 9, bracket, and then you might like iterate over that and like sum them all together or something. And even though that involves a closure, even though it involves like a struct and a totally opaque struct in the library, even though it involves generics, because you want to be generic over different types of integers in your array, despite all of that, at the end of the day, that compiles down to, I remember looking at this in the assembly, it's like 3 subtractions, an add, and a right shift or something. It's incredibly efficient. Even it's like, you can do this for any x. So like any number 0 to x, you can write a function, and it'll be like, yeah. I mean, obviously, it's actually so good, in fact, that if I did it with a fixed number, like 0 to 9, it would just replace the entire like map fold operation and closure with the result, the actual numeric result of the thing. And so you have to fool it in some ways. It's really, and again, this is all largely thanks to LLVM, but also because Rust is designed to be able to inline so many things, and its generics are like just so powerful in terms of their ability to be boiled away, and that's a zero-cost abstraction.
Does it have things like templating and like a C preprocessor? Does it look like that?
There's no C preprocessor. There's no textual substitution. Although we do have macros. But they're not C-style macros. And so we use macros in the term that Scheme uses macros. Maybe you've heard of Scheme. It's a variant of Lisp. And yes, they are kind of like, they're like patterns where you tell the compiler, hey, I might have some code that looks like this, and make it expand to this. And because of that, there's none of the weird hacks you have to do with C macros to make sure they don't like clobber things in their scope or like do the wrong thing. But they're obviously more restricted. We also, we don't have a template system. We have just generics. I don't want to compare them to Java because they're quite different from Java, but they look like Java. The angle bracket T, closing angle bracket, that sort of syntax. And unlike C++ templates, and like obviously in C++ template metaprogramming is an entirely like Turing complete sublanguage, it's like a weird functional sublanguage. In Rust, they're just used for type substitution. But they're also, if you keep up with C++, in the next revision, possibly in 2020, there's a proposal called Concepts, which is, the idea is to restrict various templates so that it makes it easier to define them and have better error messages. And we already have that. We've had that, for instance, 2012. And so it's really cool because you can write code and know that no matter how your users use it, it won't break, which isn't currently the case in C++ because you have to substitute first and check and see if the types that you have actually match what you expect it to have.
Cool. And I want to hit the other 2 points, but I first want to take Virgil's question from the chat room, which is use Rust to create a browser such as Firefox or even Chrome. Would it be possible to make it less of a resource hog?
Yes, absolutely. Currently, actually, nowadays, one of the reasons that they use so many resources is because of sandboxing. And because of the fact that web pages themselves have exploded in size as computers have gotten faster. And so it's the reason why your computer, despite being Moore's Law 10,000 times faster than it was in the 90s, still feels as slow as it did back then in the Windows 95 days. But if you look at the memory benchmarks that I'm not a Mozillian, Mozilla published for Firefox in the last release last year, the big one where the Rust stuff came out, it's like memory usage like cut in half and speed like doubled. Wow. It's really cool. But obviously not all of that's due to Rust. So Rust lets you write code that is as efficient at memory as C++ is. It's really how you write it too, right? And so Rust can actually be way more memory efficient than C++ by default due to some things about how Rust treats references and strings. So whereas in C++, you could do a lot more copying of strings by default because you don't want to accidentally leave a reference dangling around. In Rust, our static checks means you can just like store references to strings anywhere and it's fine. Or you can just like pass around references to strings and it's fine. Or you can have a method that splits a string but doesn't actually allocate any new buffer. It just gives references to the underlying buffer that exists once, and you can have a million copies of these. And it's just like we do some things better than C++, but I wouldn't attribute all of the benefits of Firefox nowadays to Rust. It makes, I would say largely Rust and C++ have pretty much the same memory footprint, but the problem is that the web is kind of bloated these days. We'll see what we can do about that.
Yeah, and I have like 3 follow-up questions to that. I'll see if I get them all in order here. The one thing, so since Mozilla is now, Firefox is now, is it mostly in Rust or is it all in Rust or just a portion?
So the idea with Mozilla is that they want to maximize their time. There's a famous article by Joel Spolsky a long time ago about like how Netscape, how they were killed by rewriting their browser engine, which eventually became Firefox. In a strange thing. And so like there's a very acute fear that like nobody wants to rewrite Firefox. And so the Servo project, which was the Rust browser I mentioned before, started on the side. And the idea was to experiment with ways to add parallelism and concurrency to web browser engines. And it's actually pretty pernicious here because in C++, like it's really one of the hardest things to do is to take a giant multi-million line like synchronous single-threaded C++ program and try and add like any kind of threading support to it. Mozilla took 4 years to like break out the UI process into its own process or its own thread. Chrome took a long time as well. So it isn't like engineer effort or like the quality of engineers. It's just an incredibly hard problem to do without breaking everything and also exposing yourself to security risks. And concurrency is actually one of the places where Rust shines incredibly. If we have time for that, it's one of the 3 bullet points on the page. If you want to talk about that later. But yeah, well, let's move on to the next question because I figure we'll have a lot of these.
So it's
I forgot what I was saying.
Is the JavaScript engine in Rust now?
Not yet. Oh, that's right. So yeah, there's nowhere near close is the entire Firefox written in Rust. It's very strategic. It's piecemeal. It's okay. We have this one piece, and it would really benefit from being in parallel. And that's currently the CSS engine, which computes the rules, all the reflows, all the the parsing of the CSS can do in parallel, that sort of thing. And then they kind of just took out the old engine, put in the new one once they had some sensible API boundary in place, and they just ran with it. And currently, they're writing a new rendering backend for Firefox, which is kind of it's inspired by video game engines, actually. So it's heavily GPU oriented, and it's going to be really cool. It's called Web Render, and it also involves writing all sorts of really cool GPU path or font tracing things, and it's all it's open source. You can all go see it, contribute to it, check it out right now if you want to. But yeah. And so it's maybe 10% or 5% at most right now of Firefox is Rust, considering that SpartaMonkey is not at all Rust. It's only the browser engine stuff right now, none of the JavaScript stuff.
Okay, and it's funny because CSS is getting to be, I think, Turing complete at this point. So you really have to have a pretty smart engine for that. So yeah, I've seen some amazing things. I think I've seen Towers of Hanoi in CSS now. So yeah, that's the end of the deal. Once you can do Towers of Hanoi, you're done. So it's pretty cool. So you actually sort of address this, but let's hit it specifically. It's one of the 3 bullet points on the front page. It guarantees thread safety. How does it guarantee thread safety?
So like I said, I could talk about this for a while. So one of the entire thing that Rust does, it all stems from one concept, and it's called ownership. And the idea is you have some data in memory somewhere, and you have one place in memory that owns it. So one of the things that we do with a garbage collector in Java or any language like Python is we have some memory and it lives somewhere, and we want to touch that memory or read that memory from somewhere else. We create a handle to it, and at that point it has multiple references. And we can't really know in Java or Python, these languages that are very dynamic, which reference will die last, which will go out of scope last. And so we leave them around for a long time. Periodically the garbage collector will go out and it'll trace all the living references, prune the dead ones, and once there are none left, it will free the memory and release it back to your pool. So Rust kind of just cuts the Gordian knot by saying, okay, you will have one owner for a memory piece. And if you're from C++, you recognize this as the unique pointer thing. But note that imagine if you're from C++, every thing on the heap in Rust is in unique pointer by default, and all semantics are move semantics by default, not copy semantics. And so anytime you call a function with an owned thing, the original, so it'll get passed into that function. And if you want to reuse that data in the function that called it originally, you can pass it back or use a reference. And kind of our system of references is about making it easier to use ownership. But it's exceptionally, ownership is pretty simple. You have one owner for data, and then we give you a little escape hatch for things like integers that kind of a short or a char is like a single byte long, and so we don't actually care if you pass it around. It's only a plain old data type. So it's.
Well, I was just going to say, when we call it a systems language, this is, I think, and maybe Jonathan already addressed this, and I was fiddling around trying to figure something out. If Linus started today, could he rewrite the Linux kernel in Rust?
He could. I don't expect him to. I mean, we'd have people who are writing their own OSs in Rust. The one furthest along is probably called Redux. It's redox-os.org or something. You can find it pretty easily. And they have an entire, it's a microkernel architecture, vaguely Unix-based or Unix-inspired. It has its own, user space right now. It has, various GUI stuff. It can self-compile itself. So you can, I think you can use Redux to compile Redux because it runs Rust. And it's really cool. It remains to be seen whether or not any of that will ever materialize, because really, Linux is pretty good right now. We're not super worried about rewriting Linux at the moment. And it occurs to me that I didn't actually answer the previous question about concurrency. If we can move on if you want, but I can just say, long story short, that because you only have one owner of a thing at a time, and we know it at compile time, that means that if you try and use threads and you get the ownership wrong, it will just tell you. It'll say, hey, so you just can't do this, because here and here you would have a data race. You would be accessing these things from two different threads, unsynchronized, and it will stop you. And so it means that you don't get data races in Rust code that compiles, which is a huge thing, actually. If you you remember, your classical teaching from even C++ or Perl or anything like that, any kind of language where it's don't use threads unless you're a genius. And Rust is no, you don't need to be a genius. It's just the compiler will help you. And the compiler is here to catch your mistakes. It's here to check your work for you. And that's a really freeing feeling often for people who haven't done system stuff or the level threading, where it's man, it might have been difficult to figure out what I needed to do to get this compile, but at the end of the day, the design I had was the right one. Because it was guiding me towards a solution that actually didn't screw up at runtime in ways that it would be impossible to debug. Or imagine debugging a concurrent program is usually just pretty frightful. And in Rust, you just don't need to.
A lot of people are reaching for Go now when they want concurrency. Is Rust similar in that sense?
Rust isn't as opinionated as Go. So Go really wants you to use CSP and Go routines and things built on that. And Go is great. You should use Go if it fits your use case. For people who can't, we have plenty of folks, so again, Dropbox. A lot of the things were originally in Python. That's why they employed Guido. Maybe they still do even. But they rewrote much of it in Go for performance. And then they rewrote some of their Go in Rust, actually, because the Go parts, the Dropbox has a lot of data, exabytes of data, which is above petabytes of data, which is above terabytes. And so with the size of the heaps they were using for the core of their storage engine for their service, the Go programs were just kind of just pausing for quite a long time, minutes at a time. And it's going to say it's an absurd use case. It's not a thing that Go was designed for. It's not a fault against Go. It's just kind of Java would fail at that point. And so from the top, it came down, hey, we must rewrite this in C++. And someone there, the company was well, actually, let's take a chance on Rust. And so this happened actually about in 2015. And so if you've been using Dropbox since 2015, late 2015, your data has been stored using some Rust there at the very core of their storage engine. And also Dropbox uses Rust for their Windows client. So if you have Dropbox on Windows, you syncing using Rust.
Hey, let me jump in. Rust, is it a garbage collected language?
No, it is not. Not at all. That would kind of defeat the purpose, wouldn't it? GC is great for a lot of applications, but I mean, not for what we're doing.
Isn't Go a GC language though?
It is, yes.
So how does Rust handle those problems that Go apparently also handles? And so why did they decide to use GC and Rust did not, and how does that work?
So I would call Go kind of like if you imagine like C with garbage collection and CSP, which are as a form of concurrency, and that's kind of all it wants to be. It doesn't want to be like any kind of like, it doesn't want generics, which is kind of a famous one. It doesn't want like various other kind of like modern things. Like I mentioned, like, the main languages these days have maps and folds and closures. Go has closures for class functions, but they're not bothered about like having like lots of modern things or like things are kind of like frippery to them. And so it's just kind of like, and also because they have these things, because they chose to use CSP and GC for their thing, a lot of their checks are dynamic. And so they have runtime checks to make sure you're not like sharing data. Sometimes it's unclear, actually. You can, I think, sometimes get memory unsafety in Go if you share in a bad way, but hopefully these days it's mostly mitigated. But again, like, so a lot of this stuff is just, it's runtime checks, and that's not a zero cost abstraction. And like I said, we don't have any, like, we don't consider ourselves competitors with Go because our goal, again, is to make sure that people have an alternative to C and C++ for writing really high performance things. If you want to write like, a server, then choose Go or choose Python or choose Rust if you want to. We can do that. There are tools for it and they're greats and like that. But just they have different design trade-offs. They really aren't comparable. I know in the past there were like people like, it was marketed as a systems language, but it was kind of a different definition of systems than you might be used to in terms of like, you probably wouldn't write your kernel in Go. You could. Nothing's really stopping you in terms of like people have been running kernels in GC languages for decades now, but there's more overhead for everything you do. So Rust gets rid of all that for you.
Yes, I think you mentioned something that's on my list to ask about, and that's crates. What are crates?
Oh, so I mean, it's kind of a silly name for libraries. So Python has like eggs and wheels nowadays. It's been a while. Java has their jars. Rust has crates. And so that's kind of our library. And so we have a package repository called crates.io. I think we have about 15,000 crates up there right now. And so you kind of like go there, you search for, hey, I want, regex engine, type it in, you find it, you can download it. We have, whenever you install Rust, you get our build tool called Cargo. It's pretty, people tell us it's best in class. I don't want to toot my own horn, but it's pretty good. We're really impressed. It's written by the person behind Bundler, Yehuda Katz, who also wrote MERB and like various other things. Ember.js is big in that too, and JavaScript. And so he's like, has his fingers in many pies. And we just like, it's kind of like just built on his years of expertise with package dependency managers. And it's just really nice to use in terms of like, if you, especially from like C++ or C, you're probably used to saying, okay, I want to build this package from source. I need to go out and find like the header files and the dev headers and look at my like apt repository for which ones are right for how they named my distro. If you're on Windows, it's just kind of like, I got to download this binary and just hope it doesn't do anything wrong, put it in the right place. With Rust, it's kind of like you put a single line in your like text file, your cargo manifest, and it just will get the thing for you. It'll download it. It'll manage it. It'll build it. You can run testing easily. It's just really great and like convenient. And for some people coming from like C++, it's kind of a killer app just for the ease with which you can like try out new things and like discard them if you need to. So
there was kind of in my circles, it was a pretty big deal. Eric Raymond famously tried out Rust.
Oh, yes.
One of the criticisms he had of it was regarding crates, and it was the idea that some of these are great, but there's also some of them that are, really low quality, and there's not a way built into Rust or the community to give mod points up or down. 5-star versus 1-star. When you have 15,000, how do you weed out and figure out which ones are the good ones and which ones are the bad ones?
Yeah, well, I mean, people who when I first got into like programming in terms of like using Python, like I found the cheese shop, so PyPI, but there's also rubygems.org, which is similar for Ruby, and like CPAN is maybe the gold standard of this kind of thing back in the day. And it seems like every language these days seems to have one of these like package repos that kind of hosts package and lets you like find things. And I don't know of any of them that actually allow like upvote, downvotes. Even for like, I know that like Eric S. Raymond, like I said, he likes Go, and Go is very much an evolution of C in some ways in terms of like it's C with added garbage collection and like ways to keep you from going wrong. And so it's no surprise that he's an old C hand that he would like Go. Rust is a more radical kind of change, even though it looks familiar in a lot of ways. It's kind of like just the way it makes you think about like ownership. It makes you like write really clear like hierarchical programs. It's really cool, but it's definitely not everyone's taste. So, I mean, we could someday add like, voting to Chris.io. We do have like various tools. Since then, we've added like various categories and like tags, and we've added like download counters and things to make it easier. Because definitely it's a thing with every package repo, knowing how to separate the wheat from the chaff. But we're working on that.
It's clear you're not a Perl expert, because I'm now going to school you on one more thing. The CPAN has had CPAN ratings for years, so every individual module can be voted on.
I meant that CPAN is just like really good at what they do. It's kind of like, I don't know. I'm really impressed by CPAN.
The CPAN was an amazing invention, and it came along at exactly the right time, right as the .com boom was ramping up, and so it was a great place to have all these repositories. I used to write a couple of magazine columns, and one of the things I do is read the daily upload to the CPAN and use that to base one of my columns around, because once a month I've got to write something. Now the daily upload to the CPAN is something like 2 pages long. I mean, there's more activity in Perl right now than there even was during the .com boom, and in fact, it's sort of sad because there's so many companies are actually switching away from Perl because they can't find enough Perl programmers. Imagine in this day and age, I'm saying there are not enough Perl programmers out there. So if you want to learn a language, I can recommend a couple good books. Only because I've been told they're good. It's not because I'm tooting my own horn, but anyway. Hey, we're almost out of time, and I don't want. There's a lot of other questions we can still get to. We can probably go another hour. There's just so much.
Let's do it.
So I'm going to ask you the most important. I'm going to ask you the toughest, most important question, because it requires doing set math in your head. Is there anything we didn't cover today that you want to make sure our audience is aware of?
I just want to say that kind of like, for me, like I was saying before, kind of like obliquely, is that it was really hard to get into systems programming because I felt like I couldn't do it. It felt like I was just like not smart enough. I don't know if it was a weird kind of like thing that only I have, but I mean, I felt like sort of insufficient. And so I kind of like was shied away from C and like even Go for a long time, because it was back then a systems language. And I feel like Rust, like I feel so like capable. I feel like I have like superpowers when I write Rust, because I'm actually doing the things I like, used to read about, like, the old, like, people who were like actually like just pushing bits into registers, but I'm also doing it in a way that like checks my mistakes for me. And so I don't have to like spend hours debugging a segfault or like reading a core dump. It's just like, I feel like it's empowering in a lot of ways, in terms of like, even if you're like only ever do like front end JavaScript, you can try Rust, and you can like, there's ways of integrating Rust with like JavaScript even, if you want to just make some like node application faster. And that's really just, I want to like emphasize like how much like we love helping new people figure out they have this power now to write like super low level code in a way that is kind of like a built-in mentor or built-in tutor. It's like pair programming for introverts almost.
Wow.
Yeah.
Cool. And so I have 2 more questions. And like I said, we keep going another hour, but unfortunately the network cuts us off at some point. They don't let me just talk forever. So there's a playground. And so if you want to play with Rust, they don't have to install it or anything, although it's just simple apt-get for most people. But there's a playground where you can type Rust code in and modify it, and then it just runs. How does that work?
We just have a Rust instance living on a server somewhere, and we just send you code. You send code, and we compile it and give you the results. It's not actually running in the browser, although Rust, the newest thing is that Rust can compile to what's called WASM, which is WebAssembly. And so you can actually run Rust in your browser right now. It's still very early days. Some browsers don't support it very well. But it's conceivable that someday we could actually ship the entire Rust compiler to your browser. But for the moment, it's just running a program on a server. Yeah, it's pretty cool.
Oh, I thought it was actually running in JavaScript or something.
Not yet.
Cool. Yeah,
it could be. We'll get there.
Okay. Good. I'm looking forward to that. And also, what was the other question? It was something. It's too late. I gotta get going here. So, somebody. I know as soon as I hang up, there's going to be some question. Oh yeah, I forgot to ask about that, but that's okay. I do have 2 very important questions that my audience yells at me if I don't ask. One is, no, I remember the other question now. Can you do shebangs with it? Can you make like a script essentially?
We have that.
Really? How does that work? Does it compile it every time? That's what happens, right? Okay.
So we have you can write an alias or a bash script for like, doing it yourself, or we also just support shebangs natively. You invoke the compiler and there's like a run function. So.
Okay, that was the other question. But now at least I remembered it, because I was about to ask you what your favorite scripting language is, but I bet I got at least one hint.
It's Python. I'm sorry.
Okay.
I know that,
And what's your text editor you spend all day in?
Vim.
Okay.
I'm being judged.
Well, Sure. No, you're not being judged. I'm not judgmental about those. People use whatever works for them. Those two don't work for me, though.
One thing is that if you have questions about Rust, we have IRC channels on irc.mozilla.org. There's a subreddit at reddit.com/r/rust. There's user forums. We actually really enjoy teaching new people, so come ask questions there. We'd love to help.
Wonderful, wonderful. Ben, it's been wonderful having you on today, and I'm glad finally got to connect up after ATO, because there's like, I'm sure he's going to contact me sometime. There you are.
Yeah.
It's good. Thanks a lot for being on and talking about Rust. I'm sure we got a whole lot of new crap.
Having me. I had a great time.
Thank you. Right. That was Ben Striegel talking to us, Striegel, one of those. I should have my German. Talking to us about Rust. What do you think there, Jonathan?
So it's more complete of a language, it sounds like, than I thought it was. When you hear about these new languages, particularly ones that are trying very hard to be memory safe and safe in other ways, there's always this question of, well, are they perpetually 5 years away from being usable? Mm-hmm. And it sounds like Rust is at the point to where it's actually usable for real projects. And then the other thing that just I find so interesting is the shebang support. So you can now use Rust basically as a systems scripting language. And that's something I will definitely have to go play with, because we don't think about it too much, but when you think about security, one of the things that can be a real problem is when you just really quickly throw something together in a scripting language, especially if it's a bash shell, if it's bash code, you can shoot yourself in the foot really easily. And so having, one a language that's more powerful, but the other thing is a language that has all of these extra protections built into it. Having something like that available for scripting is certainly interesting. And as I said, I will definitely have to go play with that.
Well, I've been pretty excited because the Dart people have come out now with, not the Dart people themselves, but one of the packages available in their pub right now is creates essentially Dart scripts. So you can take a whole Dart program, compile it down, and have it read the command line and things like that, and use all the libraries and everything, and it builds it once and caches it for you, so that you don't have to keep compiling each time. So I got to play with that a little bit more, but I have no time anymore. I'm just so busy with everything anymore. So I did compile Rust, brought it down to my system. It took about 35 minutes to compile on my poor laptop, but it's there. It's running. I can type Rust C now, and that's all I know about that so far. Anything else before we go? We're almost out of time here, so.
No, it was a great show that we got a really good overview of Rust and where they're at, I think.
Right, and a guy with a lot of really wonderful and long answers. Definitely a well-read person who's been around the block at least a few times. So that's really, really nice. But let me talk about what's coming up. Next week we have OWASP Dependency Track, which is a software composition analysis platform that keeps track of all your third-party components used in all the applications an organization creates or consumes. Very good, especially in this day and age where security is so important these days. After that, we got Pigeon, LivePurple, Game, which is multiple chat protocols, and it's a free and open source multi-platform instant messaging client based around LivePurple that has support for many instant messaging protocols, including good old AIM, rest its soul. Won't be using AIM anymore because they cut it off. After that, the Univention Corporate Server, which is server and IT management software to regain flexibility and control. Sounds like some good buzzwords. Let's see how they actually deliver. After that, Chomper, which is an internet blocking program developed for Linux. You define a whitelist or a blacklist of websites, and Chomper will block you from visiting non-whitelisted or blacklisted websites for the amount of time you specify. That sounds like something I should be using, but I don't. That's my Facebook when it keeps popping up. It's like, okay. After that, The Lounge, which is a self-hosted IRC client. For those of you that are familiar with the Shout project, this is a fork of that. We're actually going to get a little bit about why it forked and how the relationship went after that. Just added since last week is Hubble Stack, which is a modular open source security compliance framework. It's probably similar to OWASP stuff, right? The project provides on-demand profile-based auditing, real-time security event notifications, automated remediation, alerting, and reporting. That sounds really exciting. We still have a few open slots in Q2, I think it is. I'll be opening up Q3 fairly shortly as soon as we get that completely full. You can go to twit.tv/floss, which is the homepage for this show. There's a link from there to the big spreadsheet, as I like to call it. And so you can see who we're working on. If we're not working on somebody that you want on the show, please contact the project leader or community coordinator, similar to what Ben was here for Rust, and have them email me, merlin@stonehenge.com. My address is on that page. I don't have to memorize that. We have a live stream at 9:30 a.m. Pacific time on Wednesdays at live.twit.tv. And remember, we're in the U.S., so we just went to summertime a couple weeks ago, so we're maybe an hour later than you expected. Or an hour earlier than you expected. There we go. How about that? That's the right answer. I should know time zones by now. You can follow us at Floss Weekly on Google Plus and at Floss Weekly on Twitter. You can follow me at Randall L. Schwartz on Google Plus and at Merlin on Twitter. So I want to plug that I have created a brand new Flutter and Dart YouTube channel. If you just Google Randall Schwartz Dart Flutter, it should come up pretty high on there. And I'm going to be posting screen shares, videos, the talk that I just gave at Scales posted there, for example, and I'm just going to start maintaining a much bigger presence in the Dart and Flutter community. So I'm pretty excited about all that. I think there might be a book deal in the works, but I can't announce it yet, so I won't do that. Sorry. And let's see. So I met a lot of you guys at Scale. Thank you for coming up and saying hi. We had 6 new potential guests, including VLC and VS Code. I got to go bug them again because they haven't written back, so we can get them on the schedule. But that's what I do. That's how I work my hosting role. So anything you want to plug there, Jonathan?
Just mention that you can follow me on Twitter at JP_Bennett. And any companies or people that need a good way to secure legacy hardware, that's something that I'm interested in as well. And so anyone that's interested in that can hit me up on Twitter. And that's about it for me.
Alrighty. In the interest of getting out of here on time so everybody else can get their show started, we'll see you all again next week on Floss Weekly.